So what about squares that do not have whole number length sides? So I'll give you an example here. This shape here is not a perfect square, but it is a square shape. It's definitely square. Every edge length is the same length. Okay, so this edge is exactly the same as this edge, exactly the same as this edge, exactly the same as this edge. And the angle between the lines are all 90 degrees, so this is definitely a square. Okay, but it's not a perfect square because the side length is not a whole number. Okay, so we can measure the area here by just kind of chopping it up. Okay, we can definitely see that there's 4 squares there. Okay, there's 4 here. This is half a square, and this is another half a square here. So together they make one whole square. So there's 1 square here, 1 square here, 1 square here, 1 whole square here. So when we add them all up, it's definitely an area of 8 squares. Okay, so the area is definitely 8 squares, but the side length, then we input the area 8, square root it. Our answer should be the side length. And our side length is not a whole number. It is not a perfect square number. So how do we get? Well, if we want to keep it exact, we have to keep it as square root 8. We could approximate this and say it's approximately 2.8, about 2.83. Okay, so there are squares that are a real square that are not perfect squares or don't have areas that match our perfect squares. So how do we find these? How do we draw these? Well, the easy way is to just draw this kind of start here and just go at 45 degrees like that. Okay, go at 45 degrees like that. Go 45 degrees. Okay, and we will get our 90-degree corners, and we have all the lines. All the lines are going to be the same length. So this is, again, another square, but it's not a perfect square. And we're going to count it all up. So there's 2 here, 4 there, 2 here, 2 here, 2 full squares here. Okay, so those are all my full squares. There's going to be, it looks like there's 12 full squares. Plus there's going to be 13, 14, 15, 16. And then between these two parts here, okay, between these two parts, that's another 1. Okay, between these two parts, okay, there's another 1 here. So if I count it all up, there's 12, 13, 14, 15, 16, 17, 18. Okay, so this has an area, an exact area of 18 squares. So the area is equal to 18 squares. Okay, so the side length I have to square root. Now the side length is going to be, I take my area, square root it, and I get my side length. Now the side length is exactly square root 18, which is not a perfect square. So when I do the decimal, it's only an approximation. So the decimal works out to be, okay, so we'll do square root. I'll find my square root button here. So we're going to do 18 and square root that. It's about 4.24, which is about right, because if we think of a square of 9, or sorry, square of 16, that's going to be a side length of 4. Square of 18 is going to be just a little bit bigger. Okay, so there's one way to draw a perfect square. Not a perfect square, but a non-perfect square. So I'm going to show you another way that we can draw. So that's the easy version. I'm going to give you a slightly harder version here. And I'm going to draw a square this way. And this is one we're going to practice doing. So I went 3 over 1 up. Okay, so I've got a diagonal line here, and this is not an exact length. And if I do the opposite, so 3 horizontal, 1 vertical, I'm going to go 1 vertical, well, sorry, 1 horizontal, 3 vertical, and get a point here. And these two lines are exact same length because I went the same distance, 1, 3. This was 1, 3. And notice that the angle in there, that not only looks 90 degrees, it is 90 degrees. Okay, and then I'm going to do the same. So if I went 1, 3, I'm going to do 1, 3, get a point there. Notice that, again, those lengths have to be the same. And notice that the angle is 90 degrees. And I'm going to do the same here, connect those up. Yeah, my angles are all 90 degrees. And that is definitely a square. So this is a harder version of a non-perfect square. So I need to add up the area here. And this is how we're going to break up the area. I'm going to use that 1 and 3 length and make that in a 1 and 3 triangle. So we end up breaking it up into 4 squares here. And we have a triangle here, but we know how to find areas of triangle. It's going to be base times height divided by 2. So it's going to be 3 times 1 divided by 2. That's going to be 1.5, 1.5, 1.5, 1.5. So for this one, we get a square area, and that's going to be exactly 10 squares. Now again, notice that 10 squares is not a perfect square. So this is not a perfect square. So side length is not a perfect square side length. So the side length works out to be the square root of 10, which is just a little bit bigger than 9. So it should have a length of just a little bit bigger than 3. So when we square root 10, okay, we take the square root of 10, we end up with 3.16 approximately. So when I round it, it's going to be about 3.16. Okay, and that makes sense because it's going to be a little bit bigger than a 9 square, which has side length of 3. So 3.16 sounds about right. And here is a square, and this is a non-perfect square. It's what we'll call a diagonal square. And to make this, I went 3 over, 1 up, 1 over, 3 down, or I can do 3 down, 1 over. Okay, 3 across, 1 down. I just switch my x and y's and to make my 90-degree lengths, and because I'm going the same distance each time, the side lengths are all the same. And in fact, there are many of these non-perfect squares. There's infinite number of these non-perfect squares. In fact, there are actually more non-perfect squares than perfect squares. There are infinitely more actually. So we're going to work on this a little bit. So the idea then is we want to differentiate perfect squares from these non-perfect squares or diagonal squares. So here we have areas, and I want to get we're given the side length. So this in here is a side length. Okay, so again, make sure that you can relate these to parts of a square. The 4 represents the side length. The 16 units squared represents the area, the number of squares. Okay, side length is 8. The area is 64 squares. Here the side length is 2.5. The area is going to be 6.25 squares. Okay, and if I actually sketch this out, I have 1, 2.5, 1, 2.5. That's going to be 1, 1, 1, 1. Okay, that's going to be 4. This is half, 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 half a square. Okay, so that gives me 6 squares, and then 1/2. This is 2 plus 1/2. 2 plus 1/2. This 1/2 by 1/2 is going to give me the extra 1/4, which is 6 1/4. Okay, so when we make that, that's a perfect square. Okay, and we have the exact length of 2.5 along the edges. 6.7 squared, I need my calculator for this one. So if I go 6.7 squared, I end up with, should be a little bit less than 49, so I get 44.89. 44.89, and again, the 44.89 represents the area, the number of squares, when my edge length is 6.7.